All right. Welcome, Pre-Algebra, to our Wednesday edition, September 11th. This is the video that's going to take you through the lesson today. So go ahead and pause whenever I'm going too fast for you, or go back if you missed something, especially on a section I'll talk about later. Let's begin, though. First, we should check our homework from 1-8 and 1-9. So I'm going to pull up the 1-8 and 1-9 homework keys. I'm just going to leave it on there, and you are going to just pause, take a look at 1-8 and 1-9. Okay, so here's the 1-8 homework. We did the odds, so that's going to be these guys. So you can go ahead and pause, take a look at the work if you have any questions. All right, and then here's my odds on the back side of 1-8, checking that homework. Like I said, that's 1-8 homework. You can go ahead and pause, check at that work. All right, and then the 1-9 homework, some work from all the other pre-algebra class. Here is our odds on the front side of the 1-9 homework. Go ahead and pause, check your work. And on the back side, your odds. Go ahead and pause to check your work on the back side here. Something to note on here is just make sure you're using the parentheses. Parentheses are important when I'm substituting in numbers. I read online recently that this skill of substituting in numbers here and evaluating expressions is something that a lot of teachers in high school, and I know I experienced this as well, wish that students did better. So if we are practicing this and doing it really well, you'll have a leg up on other people in the world, okay? So using parentheses is a big tip to be able to do that well. Okay, so parentheses on every time I substitute something in. That'll help me distinguish between negatives. It'll help me know when to multiply, when to add, those kind of things, okay? All right, that's the 1-8 and 1-9 homework checked. Once you're done with that, please get out your 1-11 homework. 1-11 notes. I'm not going to put 1-11 material on the test, but I am going to have us do some notes here through 1-11. I think it's important that we review the properties of real numbers. I know you guys have seen this many times before, but it's important to review because a lot of times on an ACT or something of that nature, we're going to be working through problems that ask us about these properties, okay? These properties are used to justify steps when simplifying expressions and solving equations, okay? So these are the properties that we'll talk about in this lesson. So commutative property, the main idea is order doesn't matter. So go ahead and write down order doesn't matter. Like I said, during this, you can go ahead and pause or stop or go back if I'm going too fast. Order doesn't matter. That means if I'm commuting, I like the root word there's commute maybe, or a word that's similar is commute. To commute to work means to move your body from home to work. So if I'm moving, I should think order doesn't matter. Commutative means I'm moving things around. Okay, so some addition examples. Let's say I had 3 plus 2 plus 5. That's going to be the same thing as 3 plus 5 plus 2. Notice how I flip-flop the 5 from next to the 2 to next to the 3. Does it matter? No, it shouldn't matter, right? I get 5 plus 5 is 10 here. 3 and 5 is 8, plus 2 is 10 as well, okay? So that's true of a lot of things. It doesn't matter if I include a variable or not. 3x plus 8 equals 8 plus 3x. Oops. Right, it doesn't matter which way I order things. If I move things around, it'll be the same when I'm adding, specifically with adding, not with multiplying and dividing. You notice that doesn't say, or not with subtracting and dividing. With multiplying, it does work, this property of commutative property. Let's go ahead and do an example of like 3 times 4. Is that the same thing as 4 times 3? Yeah, it is. They're both 12, right? We know that from grade school, elementary school. and lower. That's both 12, right? So I flip-flop the order, doesn't matter. I still get the same thing. Not true of subtraction, right? 3 minus 2 is different, not the same as 2 minus 3. And 2 over 3 is not the same thing as 3 over 2. So subtraction and division, there's no commutative property. Next one is associative property. That says grouping. Grouping doesn't matter for these two, addition and multiplication. Okay, so grouping doesn't matter. So let's give you an example. 3 plus 4 plus 2, and if I put those in parentheses, that's going to be the same thing as 3 plus 4 in parentheses plus 2. Okay. I group two things differently, right? I group these two terms here, and I group those two terms there, and I still got the same answer. 4 plus 2 is 6, plus 3 is 9. 3 plus 4 is 7, plus 2 is 9, right? Same answer still. That's true of things with variables too, right? I could say x plus y plus z, and those in parentheses is equal to x plus y in parentheses plus z. That still works, okay? Also with multiplication, same idea. Let's do 3, 2, and 4 again. 3 times 2 times 4, but these in parentheses maybe, equals 3 times 2 times 4, right? 2 times 4 is 8 times 3 is 24. And 6 times 4 is still 24, so same thing. I'm going kind of fast, so feel free to pause and write things down and listen to what I'm saying and watch what I'm doing here. Identity properties next. Identity is keeping number the same. Keeping number the same. There we go. Okay. So how do I keep the number the same when I'm adding? I would just add 0. So 3 plus 0 is 3. Or a plus 0, and the variable a is still a, right? How about multiplication? How do I keep something the same in multiplication? The way I do that is I multiply by, not 0, that would give me 0, but 1. 7 times 1 is 7. Maybe a times 1 is 7, that kind of idea, okay? Flip your page. Inverse property. Inverse property, opposites cancel out, let's say, cancel out. Okay, so what's the opposite of 3? And when I say cancel out, I mean 0 for addition. The opposite of 3 is negative 3 on a number line. If I think about a number line, 3 and negative 3 are opposites in terms of the origin or the 0. Or the 0, so if I'm adding 3 and negative 3, I get 0. If I'm adding a and negative a, again, that variable, like I said, it still applies. With multiplication, the same idea. I'm trying to use an opposite to cancel out. But in multiplication, I'm not going to get 0. I'm going to get 1. So I think, how do I go from maybe 4? How do I get 1 out of 4? Well, I know that if I divide, which I'm not doing necessarily here, if I'm dividing by 4, I get 1. Well, if you remember when we talked about, what was that? Why am I blanking? Multiplying and dividing fractions, that's what I'm thinking of. If I divide by a number, that's the same thing as multiplying by its reciprocal. Okay, so really what I'm doing here is I'm multiplying by 1/4. 4 times 1/4 is equal to 1. That's a true statement, right? In the same way, I might say letter A times what is going to give me 1. Well, if I kind of take this as a pattern, it would be 1 over A, whatever A is, right? Okay. Or maybe if I'm using a different fraction like 4/3, how do I get 1 out of that? Well, I want things to cancel, so maybe I'll write this vertically. 4/3, if I want things to cancel, we talked about how I can cancel vertically or diagonally. What if I wrote it like this, 3/4? That's the reciprocal, just like this is the reciprocal of this and this is the reciprocal of that. Now these guys cancel and I'm just left with 1. Okay, that's the inverse property. Property of 0 is anything multiplied by 0 is 0. Okay. Hopefully you have better handwriting than I do. So like anything, maybe that's 3x times 0. That's going to be 0, or maybe it's 17xy squared times 0. That's still 0. Right, doesn't matter what it is. Lastly, distributive property. That's a multiplication over two terms. Multiplication. Oh, let's say multiplication over parentheses with two terms. Parentheses with two terms. All right, so maybe something like 5 a minus 2. I distribute the 5, multiply both those. So 5a minus 10. 5 times a is 5a. 5 times negative 2 is negative 10. Okay. So I'll quickly do these name that property things just to kind of give us some background. Associating differently, right? So different parentheses are in different places. That's the associative. And then we could say property of addition if we wanted to. Property of addition. That would be distributive. Well, maybe not distributive. That looks like distributive. I guess they just didn't multiply here. That's weird. Distributive property. Next one, that's an identity when I'm multiplying by 1. Identity. Next one, moving stuff around. See, the parentheses are the same, but I'm just moving where they are. That's commutative. Commutative. Next one, multiplying by 0. That's the 0 property, right? Got everything moving again. Commutative. You guys get the idea. Additive inverse. That means what gives me 0? What do I have to add to 16 give me 0? That'd be negative 16, right? We talked about that up here with 3 and negative 3. And the multiplicative inverse is like if I multiply 3/7 by something, how do I get 1? So we have to multiply by the reciprocal, 7/3. All right. Next, we're going to take a little break from checking homework and doing some notes to do tic-tac-toe. Okay, so your sub should have tic-tac-toe games, tic-tac-toe papers to pass out to you. Here's the way you play. Ultimate tic-tac-toe says you play on the tic-tac-toe board that corresponds to your opponent's last place. Let's say there's two people, Bob and Sherry are playing. Bob and Sherry. I think they also have a radio show or a podcast that my wife listens to occasionally. All right, so Sherry plays here. That would mean that Bob has to also play on the center board of the whole thing, okay? Because Sherry played on the center spot on the center board. Now let's say Bob plays in the top right corner. That means Sherry needs to also play on the top right corner board, okay? So now Sherry's playing on this board. So that's the top right corner, top right corner, top right corner. Right? Let's say Sherry plays here. Now Bob has to play in this bottom or the middle left corner. So Bob could play here. Now Sherry plays up here. Now Bob plays here. And Sherry plays here again. And now Bob's got to go back to the middle. And he plays down here. So Sherry's playing down here. Or she plays up there. That means Bob's playing up here. Maybe Bob wants to play in the bottom corner now. Okay. And as you go, oops, I think that was wrong. Yep, so Bob's turn. As you go along, eventually somebody's going to win a game. So let's say Sherry wins this game. And then Bob has to play over here, right? So Bob will play there. And then Sherry will play there to block him. Now, Sherry just played there, which means Bob is supposed to play on this board. The instructions say, if you are sent to a tic-tac-toe board that is already decided, right? Sherry already won this one. You can choose to play anywhere on the board, okay? So Bob can play anywhere on the board. So maybe Bob wants to win this game, play here. It means Sherry has to play here and so on. Does that make sense? Okay. So you can go ahead and pause and play that game with a partner in class. When you're done, continue the video with the study guide. Welcome back. Hopefully you had fun on the tic-tac-toe game. Here's the study guide. I want you guys to go ahead and pause the video. Try and do 1 through 5. 1 through 5. 5. Pause the video, do 1 through 5. All right, now that 1 through 5 is complete, let's check your work. Negative 10 plus 16 is 6. 3 minus 24 is negative 21. 15 plus negative 11 is negative 26. That's going to be positive 72 because it's two negatives. And that's going to be a negative 19 because we got one negative. Okay, plus a minus is the same thing as a minus. So negative 15 minus 26 farther left on the number line. Pause the video and do 6 to 9, please. All right, absolute value means distance from... Ooh, my pencil's going to die. Distance from the 0 on the number line. Sorry, it's the end of the day. 14. That's 14 away. Absolute value just kind of takes away the minus, right? If it takes away the minus, I really have 15 minus 9 here, which is 6. I'll do what's inside the absolute value first, right? We said absolute value is a type of grouping, so I do that first, and then I take the absolute value. So negative 11, absolute value is 11. 7 minus negative 10 is 17. Absolute value of 17 is just 17. Pause the video and go ahead and do a 10 through 13. All right, 10 through 13, we're back. 74, 0.74 is your decimal. When you type 37 divided by 50 in your calculator, you get 0.74 and 74%. Next one, my decimal is going to be 0.04. I moved the decimal place twice. And my fraction is going to be 4 over 100, which simplifies to 1/25 when I divide those by 4. Next one, my fraction would be 22 over 100 when I, or negative 22 over 100 when I kind of round off there. So I can divide those both by 2 and I get negative 11/50ths. And here, same thing, negative 22.2%. Repeating percent if you want, or just negative 22% would be fine. I won't put a repeating one on your test. Move your decimal place twice, you get 1.60. And 160 over 100 is how we start that, right? It's 160 hundredths, or 1.6 tenths. That's a decimal, so let's go with 160 hundredths. We can divide both those by 20. And I get 8... Wait, no. Yeah, 8/5. Yeah, 8/5. That's right. 8/5. Cool. Pause the video. Do 14 to 16. Welcome back. 1 times 4 plus 3 is 7/4. 1 times 6 plus 1 is 7/6. My common denominator is 24. Oop, no, my common denominator is 12. Just kidding. 12. Multiply by 2, multiply by 2, multiply by 3, multiply by 3. So I get negative 21 there, and 14. So that gives me a negative 7/12 for my final answer. 15. 5 times 12 plus 1 is 61/12. And 3 times 3 plus 2 is 11/3. Keep your minus signs. I'm going to turn that negative 11/3 into having a 12. So that'll be minus 44/12. That'll be like negative 105/12. And that's divisible by 3, isn't it? 105 is divisible by 3, I think. Yeah, so I can turn that into negative 35/4. There we go, final answer. Simplified whenever we can. Number 16. Let's go with 7/3. That's a plus, right? Minus a negative always means plus. Plus, that would be 29/6. So that would multiply by 2. I get 14/6 plus 29/6. That's 43/6. Did I do that right? 6, 7, 7/3, yeah. What did I say, 43? And I can't divide that any farther. Let's do 17 and 19 then. 17, 2/5 times negative 1/6. I just multiply across. Negative 2 over 30 I could also have simplified there. That's okay. Negative 2/30 is the same thing as negative 1/15. All right, and 19, same idea. Negative 25/7. 3 times 7 plus 4. Divided by negative 15/14. And I multiply. So negative 25/7, I got to multiply by the reciprocal. That's negative 14/15. I can go ahead and simplify things. Divide by 7, I get 1 and 2. And I divide by 5, I get negative 5 and 3. So that's negative 5 times 2 is negative 10 over 3. Easy peasy. Just a reminder on number 22. When I say I want 3/4 of something or 1/2 of something, I'm going to go ahead and multiply by that value, right? If I wanted half of one of the persons in our class's height, I would multiply by a half, not divide by a half. Just remember that. Pause your video and do 24 to 29, please. All right, 24 to 29. Should I get like what is that? 139,000. 139,968 is what my calculator says. This next one, you're going to get 16, is that? Yeah, 16 times 3,456. So that'd be 6 to the 3rd power as well. Yeah, 216 times 16 is 3,456, and that's negative. 26. 3/10 to the 3rd power. Remember, I can just distribute my power there, or use my calculator. It should give me 27/100 times 400. I can just knock the hundreds off there because it's like multiplying fractions. It's like 27 times 4, which is going to give me 80, and 28 is 108. Always when I'm seeing negative exponents, I need to move it to the bottom of the fraction, right? So 1 over 2 to the 5th, which is like, I don't know, is that 64 or 32? 32. 1 over 32. Same thing here. Negative power goes to the bottom. Anything to the 0 power is 1. We learned that as well. So that's just going to become a 1. So that when I'm multiplying by 1, it doesn't matter, right? So 1 over b to the 3rd, c to the 1st. These move to the bottom because they're negative. 29. 1 over 8 squared times 6 cubed. Right? The negative power moves it to the bottom. And then I can just leave my 6 cubed on top and then evaluate. So 6 cubed. That'd be 216. 216 divided by 64 is, it's like 27/8 when I divide those both by 8. 27/8. If they want it as a simplify as if possible, that means we want it as a fraction. It's 27/8. All right, finding its square roots, just typing in square roots. So this is 17. This is 4. Your calculator should give you a 2/9 on this one. I'm just taking the square root of the top and the bottom there. And skip that one. We're not going to have one like that. All right, I want you to do 34 to 36. Try and do those by yourself next. So pause the video and do that. All right, welcome back. 1, 4, 9, 16, 25. These are my perfect squares, right? 36, 49, 8 is 64, 9 is 81, 10 is 100, 121, 144, 169, 196. Keep going. So 18, that's going to be smack dab between 16 and 25. So that's between 4 and 5 because 4 squared is 16 and 5 squared is 25. 360, that's a bigger one. So let's get out to, what I say, 225 is 15. 16 is 256. 17 is 289. 18 is like 324. 19 is like 360 something. 361, yeah. So that's going to be between 18 and 19. And 36, that's going to be right there between 14 and 15. Okay, I'll give you this list on the board for your test. Your test on Friday, by the way. Friday? Yeah, Friday. Last couple sections. Go ahead and do 37 to 43, and then we'll do that one. All right, cube root of 729 is 9, or no, 7. Let me double check. I feel like that's 9. Yeah, it's 9, good. Cube root of 27, just pretend like that's positive, is 3. And cube root of 2,744 is 14. Scientific notation, start with my decimal place there. I'm moving it until it goes to be between 1 and 10. 5.028 is between 1 and 10. I moved it how many times? 3 times. So times 10 to the third, right? It's got a positive exponent. It means it's a bigger number that I made smaller. It's got a negative exponent. It means it's a small number. 1, 2, 3, 4, 5. Let's try looping that again. 1, 2, 3, 4, 5, 6, 7. 2.16 times 10 to the negative 7th. That's how many times I move my decimal place to get it between 1 and 10. Same thing here. There should be a small number, so let's move it to the left. 0.097 with the scientific notation. Negative exponent, small number. Positive exponent, big number. 1, 2, 3, 4, 5. Let's fill in those with zeros. 342 and then 3 zeros. That's 342,000. All right, try and do number 45, please. And then we will practice that one here in a second. Pause. 45, 1/3 is 0.3 repeating. I would write these all as decimals and then go ahead from there. 0.03. 2 to the negative 2 is like 1/4. It's like 0.25. Let's write that out. 0.25. Next one is 0.034. Next one, 2/5 is like 0.4. And square root of 10, I don't know that one off the top of my head. Oh, my calculator's broken. Let's try square root of 10. The screen's all screwy. 3.26, is that what that says? Probably, it doesn't matter though. That's gonna be my biggest one. They want least to greatest, or greatest to least? Greatest to least. Oh, 45 is greatest for the least. Greatest is 3.26, that's square root of 10, right? My next greatest is that 0.4, that's 2/5. My next greatest is the 0.25. That was 2 to the negative 2. My next greatest is 1/3. 0.3 repeating. Next greatest is 3.4 times 10 to the negative 2. And my next greatest is 3%. Practice, let's do 48, 49, and 50. That's what we did in my other class. 48, 49, 50, please. So practice those, and we'll talk through them. All right, welcome back. 48, absolute value of 24, or negative 24 is 24. 5 minus 24 inside there. 3 in front minus square root of 361 plus 2 to the 6th. Let's go ahead and do that right away. 2 to the 6th power is 64. Okay, 5 minus 24 gives me negative 19. Minus, so we said square root of 361 was 19. 19 plus 64 is 83. And 3 times negative 19 is negative 57. It's going to give me negative 140. Number 49. Big grouping symbol here, big grouping symbol there. Recognize those. Let's go ahead and do the top first. 27 minus 3 squared is 9, minus 2 times 5, over 8 minus 6 squared. We have a multiplication inside a grouping. Let's do that next. 27 minus 9 minus, that's going to become a 10, right? Because I did 2 times 5 there. All over 8 minus 6 squared, we noticed 36. Keep going. 27 minus 9 minus 10 is negative 1. 8 minus 36 is negative 24. Nope, negative 28. 8 minus 36 is negative 28. Yep, there we go. Okay. That's 28 on top. 27 minus negative 1 is like 28 plus, or 27 plus 1. 28 divided by negative 28 is just negative 1. Look at that. How nice. Last thing we're going to do here is 50. Let's go ahead and evaluate 50. 8 negative 2 in parentheses, negative 4 in parentheses, minus 7, negative 2 squared. All right, let's multiply everything. 8 times negative 2 times negative 4, that's like 8 times negative 2 is like 16, times 4 is 64. That's positive 64 because I got 2 negatives there. Minus negative 2 squared is like positive 4. So 7 times 4 is 28. Let's put that here, 28. That's all this stuff became 28. 64 minus 28. Oops. Gives me 36. Final answer. All right, so hopefully that was helpful. Hopefully you feel ready for the, oh, I did the wrong number. I just realized I put X in for Y. Let's reevaluate that. Negative 4. Negative 4 squared is actually 16. So 7 times 16 is 80 and another 42, 122. Okay. 112. Oops, 112. All right. Really struggling here at the end, obviously. 112. Like I said, it's the end of the day. 64 minus 112. That is negative 48. There we go. That's our final answer. All right. Hopefully this helps. See you guys at the test.